Hi, I am Mohit Agarwal. I am PhD student of Bennett University. I will try to explain convolution neural network with TensorFlow on MNIST database dataset. I am courtesy to Jesus Fernandez, and the slides are taken from this link. Now, what are the contents? How we will install TensorFlow? What is TensorFlow? How do we implement softmax regression and deep convolution neural networks in TensorFlow? Now, install instructions. Create a virtual environment with Anaconda. It will take some time using conda update conda. We will install TensorFlow using conda create -n TensorFlow Python equal to 2.7 space anaconda. Activate our new environment. Source activate TensorFlow. To deactivate, we'll do source deactivate. Now we will test the new installation using TensorFlow. Import TensorFlow as tf hello equal to tf.constant hello TensorFlow ses equal to tf.session print ses.run hello. So it will print hello TensorFlow. Similarly, we can do mathematical operations like a equal to tf.constant 10, b equal to tf.constant 32 and print ses.run a plus b, so it will print 42. TensorFlow is developed by Google Print Team and it's Google's machine intelligence research organization. It is interface for expressing machine learning algorithms and an implementation for executing them. It has deep flexibility. It has true portability, auto differentiation and language options like Python, C++. It maximizes the performance. In TensorFlow, computation represented using graphs. Data is represented as tensors. Tensors are matrix form, which can be scalar, vector or matrix. It is two-phase in program, construct the computation graph and execute the graph in context of a session. There are always same three-step pattern: inference, build the graph as far as is required for running the network forward to make predictions, loss, adds to the inference graphs the ops required to generate loss, and training adds to the loss graph the ops required to compute and apply gradients. This is a MNIST dataset. Each image is 28 by 28 pixels. There are 55,000 data points of training data, 10,000 points of test data and 5,000 points of validation data. Now this is the equation for the neural network. Y equal to softmax wx plus b. Softmax is exponential xi divided by sigma exponential xj over all j. For MNIST softmax.python, we can do import TensorFlow as tf, then import input data in MNIST is equal to input data.read dataset, MNIST.data underscore data. This is taken from the reference of tensorflow.googlesource.com TensorFlow, and the variable declaration are of the form x equal to tf.placeholder, tf.float32 none coi 784, y is underscore is tf.placeholder float32 none by 10, and w is a variable of size 784 by 10 because there are 10 possible outputs 0 to 9 digits, and b bias tf.variable of tf.0 is 10. Then we can inference with the softmax y equal to tf.nn.softmax tf.matmal x comma w plus b, and cross entropy equal to tf minus tf.reduce sum y into tf y underscore into tf.log y. This is a loss function. Then we will train using the gradient descent optimizer. TensorFlow also provides many other optimization algorithms, which may be like ADA-grad optimizer, momentum optimizer, ADAM optimizer. Now, how well we are predicting the correct label? We are finding using correct prediction by tf.equal tf.argmax y comma 1 comma tf.argmax y underscore comma 1, and then accuracy is reduced mean tf.cast correct prediction to float. How do we execute the computation graph? We will initialize all the variables do ses equal to tf.session, ses.run init, and then for I in range 1000, it can be anything like 1000, 5000, 10,000, how much we want to iterate over our training set, and then batch from the MNIST dataset, and then ses.run train underscore step feed x equal to x from x batch x and y from batch ys, and then print ses.run accuracy. This will return about 91% accuracy for normal neural network. To increase this accuracy, we will use convolution neural network. The diagram for convolution neural network is shown in this, in which from 32 by 32 image we will resize it to 28 by 28, which further maps to 14 by 14, and it can be convolved to map to 10 by 10 and then 5 by 5, which will finally give the features which are having from 0 to 9. So explanation of each layer is trained using backpropagation, and this works very well. How we reuse the data loading part of MNIST. We will import TensorFlow, import input data, make the same x and y placeholders, and then make a variable, define a weight variable which is initial tf.truncated normal, shape standard deviation is 0.1, and return tf.variable. Then we can make a function bias underscore variable with initial equal to tf.constant 0.1 and return tf.variable initial. Convolution and pooling operations, we will use them in different layers. Convolution is a function which returns tf.neuralnetwork.conv2d. It is a TensorFlow API in which we are convolving it with the vector 1, 1, 1, 1. Similarly, for max pool, we will define a max pool 2 by 2, which is a tf.nn.maxpool, and it is convolving it again with vectors like 1, 2, 2, 1. Now what is the first layer? From input data to second layer. Weight of convolve neural network will be weight variable, which will be convolved with 5, 5, 1, 32, and bias will be of 32 size. So it will convolve the input image from 28 by 28 size to final 5 by 5 size. So we will reshape the input image by reshape and then call tf.neuralnetwork.relu, which is rectified linear unit activation function, and call the conv2d on the input image convolved with the weight and adding the bias to it. Then we will have the hpool1 is equal to max pool, which is 2 by 2, and convolve with hconvolve. And the second layer is the first from output of first layer to the FC layer. Again we will have a weight matrix which is 5 by 5, 32 by 64, and bias which is of size 64. We will convolve with the tf.nn.relu and convolve using hpool1, w conv2 plus b conv2, and hpool2 is a max pool in 2 by 2 in passing the hconv2. Now we will get a fully connected layer with weight variable, the wfcl 7 by 7 by 64, 1204, and bfcl is equal to bias underscore variable, which is 1024. So it will reshape initially and call the rectified linear unit activation function of neural network by matrix multiplying hpool2 with wfcl and add the bfcl. Now dropout trick for output layer. Add the dropout key probability tf.placeholder float and hfcl dropout tf.nn dropout hfcl key probability, and then read out the layer WFC2 weight variable 1024, 10 and B bias variable 10. So this is the final layer WY conv is equal to TF.NN dot softmax matmel HFCL drop comma WFC2 plus BFC2. So these are the details of the convolution neural network which I have explained in last 4-5 slides, in which each layer is convolving with the matrix and reducing the features from 28 by 28 to uh, 14 by 14 to 10 by 10 to 5 by 5 and then finally a 10 value vector. Then we will train and evaluate and using the Adam optimizer and then get the prediction value which will tell the accuracy of the convolution neural network. We will use this code init is equal to tf.initialize all variables, sess equal to tf.interactive session sess.run for I in range 20,000, as I have told that it can be 10, 1,000, 5,000, 10,000, how much training epochs we are using, and then batch is equal to MNIST.train.next batch 50. We are taking 50 by 50 batches from the training dataset, and then training accuracy we are finding and printing the training accuracy and also printing the test accuracy. We will get this accuracy of about 99.2% using the convolution neural network, and this is this is a great increase from the previous accuracy of 91% from a normal neural network. This calculation of convolution neural network can be clear if we read the theory of convolution neural network, in which we are convolving with predefined matrices to reduce the features and get the finally classification of the data. I will be explaining my work in the next presentation, which is the working of the code in Anaconda with the TensorFlow. Thanks.